Recently I did a video on some 3D printing, and while I was doing that, I just happened to mention that I use an ESP32-CAM to monitor the whole shebang from wherever I am on the network, as opposed to, I guess, what a lot of people use, which would be something like maybe an Android phone can be used in concert with Octoprint or a Raspberry Pi. I have used an Orange Pi Zero for that before, but I've settled on the ESP32-CAM. The only problem was, in the original configuration, I wasn't able to access this LED here. And this is actually quite useful, because when you're printing, as I am sort of downstairs inside, I guess it's an enclosure, that protects the print and makes sure everything's sort of at the right temperature and all that sort of stuff. But it is quite dark in there, so I could either have a permanent light or, better still, turn on the camera, turn on the light when I need to. So in the end, it was really important for me to do like an operating system upgrade or firmware upgrade on this ESP32-CAM. So I thought in this video I would look at how do you program this in the first place, like how do you actually access it, and then after that we'll look at the standard software that's available pretty easily for this particular module, and then there's a whole heap of different firmwares that you can download. The one that I chose, I like in particular. It just suits me really, including access to this light. But it also has like two modes of actually upgrading to that firmware. You can just use their binaries, which is fine, and that's actually pretty straightforward and trivial. Or you can compile them, which I will do as well. So basically it'll go, let's program this, how do you do it? Let's use the original or standard software for it. Let's do the upgraded software, but binaries. And finally, let's compile and upload our own, a version of the firmware which does what we want it to do. So just to show that you don't need anything fancy, this Uno has been programmed, Arduino as ISP, and that's straight from the examples folder. And then you just connect up RX to RX and TX to TX from the Arduino to the ESP32-CAM. The Arduino also has a connection between ground and reset, and then we've got power coming out of the Arduino, and that's just 5 volts coming to this rail down here, and a little cap in there. I think that's something like, I think a minimum is like 100 microfarad. I think that's 1,000 that's in there at the moment. For the ESP32-CAM side, you just need to power it with 5 volts and down to ground. And then I've got this little connection to this button, and what it does is it puts it into programming mode. And you'll know it's in programming mode when you connect it up with this pushed in, and there's a little flash of the light indicating that you are in programming mode, and that's good. So then all you need to do is to upload. I've just got a blink sketch here, and I've got it going to pin number 4, which is the pin for the built-in LED. So if we just, and I'll show you the connections up here on the Arduino, what you need to do for that, but basically it just connects straight up. It's a very short sketch, so it's already good to go. And you might be wondering, why isn't it blinking? Because it's still in programming mode. So we'll just take this out, and then we'll turn it out of programming mode, plug this back in, and we should get some 1 hertz blinking action. So that's terrific, and that's really all you need to do it. But I was thinking that I might be able to do something a little bit fancier. So let me just grab a couple of things and I'll get back to you. So I started programming the ESP32-CAM first, and originally I did it exactly the same way that we've just seen with the ESP32, that is using an Arduino Uno as AVR ISP and just connecting it up on a breadboard, and it was fine. But I got to thinking that it would be a little bit easier if I made up my own programming board, which I did. So this is a typical arrangement here. You've got your ESP8266 on an adapter board, and it just sits in this cradle here. And then you've got your usual connections to TX and RX, a big stonking capacitor there, and a few buttons, and even a separate power supply. And then your USB ASP just connects up to these pins here and you are good to program. And that was fine. And then sometime later along the track, these little guys came out, and that's got a CH340 in there for serial communication. And then this just sits on the top, and it just connects up to your Arduino, to your computer as normal, and you're good to go. So that's the easiest option, I think. And in fact, I ordered one of these similar, well, it actually contains a ESP32-CAM module on the top, and then the programming part down the bottom with the CH340 connector. And one actually arrived into the country, I think January 2020. Can I find that now? No. So I've ordered another one, which is a bit of a shame, and it's a bit frustrating. But I thought in the meantime, I've really got a couple of options. I could mock up one of these, very similar for the ESP32, while I'm waiting for the programming module. Or I've had these guys around for a while and never used one. So these are sort of like generic shields that you can use for an Arduino Uno that just sit on top. And let's see, this way around, I'm assuming. Yep. And then you can make your own programming shield. And with that, I might be able to get a cradle up here for the ESP32 and connect all this up and have it do that for me. So I think the first thing I'll do is I'll wire up this guy, solder it all up, and then see if we can't get to program the ESP32-CAM on this shield sitting on top of the Arduino Uno. That's the first phase complete. Seems to be sitting up there rather nicely. And now I've just got to wire it up. So I'm going to use red and black for 5 volts and ground. I traditionally use green and yellow for TX and RX. And then I'll use this guy for going back from IO0 to ground for the programming button. Yeah, so let's do that. All right, so without going over the boring bits too much, I did have these the wrong way around to start with. Everything else went pretty well. There's my TX and RX lines, and here are my lines from IO0 out to the button and back to ground. So all we need to do is to assemble it and program it and hope that nothing blows up. So a couple of things which I didn't hardwire in is the wire between reset and ground and the capacitor. So I've just shoved them into the respective headers there. So now, this is the original ESP32 that I programmed before on the breadboard. So it should, if this is, yep, that's just normal mode, it should, when I connect it, just flash at 1 Hertz as programmed before. Yep, good, nothing blown up, that's a good thing. So now what I'll do is I'll pull that out and I'll put it into programming mode and put it back in again. All right, so I didn't see that flash, which worries me a little bit. Let's go for a program that maybe has a shorter flash but a longer delay. So we'll go for a 100 millisecond flash, which is a blip, and then we'll go for a 2-second delay. Okay, so it's compiled okay and it's uploaded okay. Alrighty, so back out of programming mode, back in again, and a blip and 2-second delay. Hey, that's pretty good. Now there is actually a reset button underneath, which is a bit awkward to get to. And also I'm thinking that another couple of buttons which would be useful, not just reset on this board, but also a power button for this board as well. And then maybe hardwire this guy in and hardwire this guy in. And yeah, but anyway, look, this is just proof of concept. Now what I'm going to do is take this upstairs to my main computer so that I can upload the ESP32 camera software in this so you can actually see something from this. We'll do the standard software first, and then we'll do the newer firmware, and then we might compile it.
Okay, so the first thing we need to do is to find the examples that come with the ESP32 libraries. Oh, if you don't know where to get the libraries from, then under Preferences, you can actually enter in all of the different libraries that are available that you can find. Usually they're GitHub libraries. Let's see if I can just make this a bit bigger. And here's the one there that we want from Expressive. Okay, so you just copy and paste that from the GitHub, and then you just go to your boards and you go to Boards Manager, and then you just type in ESP32, and that's where you get all these lovelies from. And the one that we're looking at is the CAM. Let me just go to that again. So that's ESP32-CAM. Where are you? I always find it hard to find this guy. Yeah, there it is. AI Thinker ESP32-CAM. There are a mountain of different options there, so that's a tough one to find. And then we've got the 40 megahertz flash frequency, QIO. You can fiddle around and read up on all of these different ones. I've gone for the huge APP. There's my port, and no programmer. Even though I've got ESP tool available, I'm actually just going through the Arduino, so I don't select anything for there. And then when you install that, you also get via examples, you get the ESP32, and there's one that here that's called Camera and Capra Web Server. And then what you need to do is to choose here which model that you've got. I'm going to go with the AI Thinker, and then you enter in your Wi-Fi credentials, and then you just upload it. So let me just get those credentials changed, and it'll come back and upload it. Okay, so it should all be good to load now. So it's just compiling. First time you do any of these sketches with this ESP32 library, it does tend to take a fair while, even on a reasonably quick machine. And this will take longer to upload too. It's a fairly big program compared to the little Blink program that we did before. And then what we'll do is we'll try and identify the ESP32 on the network and see if we can't see a picture. So it looks like it's finished. Yep, and good to go. Let's go find it on the network. So this is the standard interface once you find the IP address on the local network, which I found here via my router. And there's lots of different things to change here, but we'll just start with getting a still. And you can see they're very small, so we can change it to something like, let's go 1280 by 720 and get still. Yep, and that's fine. And then we'll go to start stream, and that's working well as well, except that you'll notice it's very low light, and there's no way that you can actually access the little LED which is on the board, which is a bit strange. And so if you wanted to light your subject, you need to actually to have external light, which is fine as well. But I wanted to access that LED. So let's go find some software that allow us to actually access the LED, as well as perhaps lose some of these things like face detection and face recognition, which I certainly didn't need to do 3D printing. So there are many different types of firmware that you can use for the ESP32-CAM. I've gone with this one here, which is ZenPack ESP32-CAM Linux Motion. And you can see all of the different stuff here, including binaries, and it's also got the source. And then you can read a little bit about how you can, actually load up this software. One of the interesting things about it is that you don't have to put your Wi-Fi password in there. It says it's configured via the serial interface, which is pretty cool. And yeah, it's got, let me just see. Yeah, it's been updated about, what, 4 months ago, so that's not too bad. But, there's a lot of different software out there for this particular module. So, you just hunt around until you're happy to find the one that you want. This one works pretty well for me. So, what I do is I just go to code and download the zip and then unzip it, and then we'll go from there. Right, so here we are in the directory for that download, and you can see that there are binaries that are available. So we'll just go into binaries, and then we have 3 bin files and a couple of other things. If we look at the instructions for flashing, it says that you need the ESP32-CAM program. Now, depending on what operating system you've got, even under Linux, there'll be different ways of doing this. So I'll leave it up to you to find the ESP2 program. But then you've got this line down here. And so it looks like, I think I've got this in, yeah, that's the one that I've used. Okay, so ESP2, then it tells you the chip, the port, the board, and you can see that I've slowed it down a little bit from the main one. That looks like all the same, right? Flash, flash 80, you can change that to 40 if you like. And then, well, everything's pretty much else is the same. So we'll just try that, and that's all there is to it. So it'll take a little while to upload. But yes, the requirement really is just ESP tool, and that's it. On most Linux installations, actually, you can just upload it from the repositories, but I think I went and got it from Expressive to start with. It's up to you. So yeah, obviously a pretty big file to upload, and it should just do that hard reset after it's finished. So yep, and it's done that. Alright, so now we just need to go and find that ESP on the network again and see what the differences are. Well, with this particular piece of software, you don't have to enter your SSID or your password. You do need to contact, however, your device when you first load up via the serial interface. So I'm using PuTTY to contact it, and I've specified that it's a serial connection. That's where the device is listed, and this is still sitting on the Arduino there. And then the last thing is to say I want a particular baud rate. Now, when you contact it, you don't get an awful lot of information until you press your reset button on the ESP32. Then you've got 2 seconds to enter a menu where you can actually edit the information. So I'm going to edit 0, and I'm going to enter my SSID, and then I'm going to enter the password, and we'll come back when that's done. So here's the new interface, and again I'll leave you to explore all the different options. One thing that's missing, you'll see, is the face recognition and all that sort of thing, so that actually makes this software a lot faster. So it's optimized quite a bit. That's what the still looks like on low resolution. Let's go to higher, let's go to this guy and get a still. Yep, so pretty good, but one of the things is that you can actually have a flashlight for that and take the still, and that gives you a much better picture. So that's using the light that's on the board itself, so that's great. Let's get a stream, So that's what the stream looks like. I'll just put my hand in there so you can see we're all live. Lovely. And then we'll go to the stream light, and that's pretty bright. So that's pretty awesome. And that means that I can log in from wherever I am on the network, have a look at the, start the stream light, have a look at the 3D printer and see what it's doing, and then turn off the stream, and then it'll just go back into waiting for me to log in again. So that was with the compiled binaries, and that's all fine, and that's probably what most people want to do. But let's have a look at compiling those binaries from that same site. In order to compile those binaries that we loaded into the ESP32-CAM, you're going to need the IDF. And if you're a Windows person, pretty straightforward. Go to Google, do a search for ESP IDF and download, and you'll most likely find this page here. If you're a Linux or a Mac person, you just add the Linux and or Mac to the search, and you'll get this page here. This one requires a little bit more copy and paste of commands just to make sure you've got all the tools that's necessary, and then eventually you get the ESP IDF. Probably after installation, the thing that that took me a little while to understand was that in the, let's just have a look. There's the directory there, the ESP IDF, and inside that directory, there's a few files. And once you've used the install.sh file, the export file is necessary not to execute, but to source every time that you go to do this compilation. So, for instance, if I wanted to compile the code now, then I would go source and ESP IDF and export. Rather than actually run the file itself, you use the word source. It goes away and does its magic, and now we are good to, if I've got a make file in the main directory, yep, there it is, there's the make file there. So I'm just going to go straight stock standard with make, and it'll go away and do its thing, which will take some time. So I'll probably just fast forward this bit, and you can always, I guess, slow it down if you like to watch builds. So the compiling is complete. We have our old binaries and we have our new binaries. For instance, if I just look at the old binaries, one of them is called bootloader. So if I just do a search for the bootloader binary, you can see that that is the old one, which is provided with the download, and this is the new one that we've just built. Now you could go and find all those binaries, well there's only 3 of them, but you could find them and put them into one directory. But there's another cool feature here. You can just go make flash, and it'll go and find the those binaries that we've just built, and it will just upload to the ESP32-CAM directly, which is pretty cool. So I guess the advantage of being able to do that sort of binary build is to make any changes that you'd like to in the actual code itself. So if you're sort of person that likes to customize, even just the layout of the HTML file that you go to for the web server for the ESP32-CAM, then that is the process for doing it. So it looks as though we're nearly finished here. Yep, so it's reset. So let's go and see what it looks like when we log in and try and get a picture. So here is the newly compiled version. Looks pretty much the same. Yep, I'll just turn that camera around a little bit. Let's go with the stream. There we go. We can see the live action as much as you can say that's action. And let's go with a better resolution. Yep. Nice. Ooh, actually, I don't like that at all. Let's go with this guy. Okay, pretty good. And then we'll go with the Streamlight. Yeah, nice. And put hands in there to show it's all live. Beautiful. So yeah, look, that's a fair bit in that. Please, check out the blog and for all the links and everything like that, and perhaps a better explanation than what I've been able to provide on the video. Let's call that the circuit working for this week. We'll see you next time.